Hello, and welcome to Quadratic Functions and Models. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. Alright, so what is a quadratic function? A quadratic function of the variable x is a function that can be, notice can be, written in the form f of x equals ax squared plus bx plus c, or we might use y equals ax squared plus bx plus c. The numbers a, b, and c, they'll be numbers, alright, they're values. They'll be numbers, fixed numbers. And a can't be 0, because if a is 0, then we just have bx plus c, which is a linear function, earlier video. Traditionally, we write these in descending order. We always write our polynomials in descending order. So put the highest power of x first, and then work your way down until you get to the constant terms where there is no variable at all. Alright, here we go. Let's work with quadratic function. The graph of every quadratic function is shaped like a parabola. Now, a parabola, even though it looks like parabola, I still say parabola in my head, but it's a parabola. If the a value, remember ax squared plus bx plus c, if the a value is positive, the parabola opens up. Now, I think of this as positive people smile. If a is negative, the parabola opens down. Negative people have a frown, which goes down. It's stupid, but it works for a memory trick. Most memory tricks really are just a stupid memory trick. So that works for me. Positive people smile, it opens up. Negative people, a frown goes down. There we go. Second part of a graph. The vertex is the turning point of the parabola, and it could be a maximum, could be a minimum. It kind of depends on which one we're looking at. And if I have a parabola that the a value is positive, my turning point, my vertex, is a minimum. If I have a parabola where the a value is negative, and it goes down, my turning point, the vertex, is going to be a maximum. Either way, as we're looking at y equals a x squared plus bx plus c, we are looking at the a's and b's, and eventually we'll look at c for another application here, in order to get the x coordinate of the vertex, so x equals negative b over 2a, and this is the b and the a that I'm referring to. The corresponding y value, well, once you know an x, what do you do for every function? You put the x in, right? Put the value in, and you find the y that goes with it, and that's all this is saying. So once you find x equals negative b over 2a, put it back in replacement for x, find your y value that goes with it, and you find the coordinates of the vertex. X-intercepts of the graph occur when the y value is 0, right? It's where it crosses the x-axis. The x-intercepts occur when f of x equals 0. And we'll use the quadratic formula a lot of times on this. Quadratic formula will always work, whether we have real or complex zeros. But you could factor. Factoring sometimes is an easier or quicker way of getting there. The y-intercept occurs when the x value is 0, right? When the x value is 0, think about that. Well, a times 0 squared plus b times 0, those both become 0. And the y-intercept is always 0, c. 0, c. So the c value, the constant value, will always be our y-intercept. The parabola, the graph of our parabola, whether it opens up or down, doesn't matter, is symmetric, or a mirror image of, with respect to the vertical line through the vertex. And we know the vertex occurs when x equals negative b over 2a. So the line of symmetry is a vertical equation, x equals negative b over 2a. If I were to somehow magically take this off of my iPad and fold it in half, the right side of the graph would exactly lie on top of the left side of the graph if I graphed it correctly. So the line of symmetry is the mirror in which the right side is a mirror copy of the left side. Notice the x-intercepts are the same distance away. If I have a y-intercept that is 1 unit away from the vertex, then at the same height, 1 unit on the other side, I'll have a point on the graph as well. So the parabola, the axis of symmetry, the line of symmetry, allows us to only have to find half the points because now we could just find the mirror images of the others. Let's look at some examples. So we're going to sketch the graph, finding all the intercepts, the vertex, the line of symmetry, all the important key values. So if we have f of x equals x squared plus 3x plus 2, the first thing I'm going to do is I'm going to write down a equals 1, b equals 3, and c equals 2. Alright, I always find the vertex first. And until I get used to it, I'll probably even write x equals negative b over 2a. I write it for you until you learn it, and you'll write it for you until you're sure you've got it, and then you could jump to this step. So the x value of the vertex is negative 3 over 2 times 1. You can multiply by 2 in your head. 2 times 1 is 2. Negative 3 halves is the x coordinate. Now you can use a calculator or evaluate by hand. Put negative 3 halves in everywhere we see an x. And after we do negative 3 halves and square it, plus 3 times negative 3 halves plus 2, a little bit of magic occurs and we end up with a y value of a negative 1/4. So the x value negative 3 halves leads to a y value of negative 1/4. That is the coordinates of my vertex. And I can plot it on my graph. I know that the y-intercept is always this c term, right? Y-intercept has an x value of 0, so the x squared goes away, the 3x goes away, all I'm left with is a 2. So I could plot my y-intercept of 0, 2. Once I have my vertex, I also have the equation of my line of symmetry. It says it right here, x equals negative 3 halves. So I could draw a line. X equals negative 3 halves, always a vertical line of symmetry. It's not technically part of the graph, but it is a part of the graph that helps us find other values, so I put it in as a dashed line. Let me see, we wanted to find the vertex, got it. Line of symmetry, got it. All the intercepts. I found the y-intercept, now let's find the x-intercepts. The x-intercepts happen when y equals 0. So if 0 equals x squared plus 3x plus 2, I chose to factor this rather than using the quadratic formula. So, let me see. Two things that multiply to be 2. The plus sign tells me they're the same sign. This tells me they add to be 3. It must be x plus 2 times x plus 1 in order to factor it. If you need a little help on factoring, a little practice, check out my website. It's through UTEP, so just do a quick search on math, UTEP, Tuesday J. Johnson. It'll come up for you. And I have on the right side menu, extra practice. Go to algebra, factoring 2 the handout with factoring 2 talks about how you would factor this. Using the zero factor property, now that we have it factored, if two things multiply to give me 0, then either the first one is 0, so x plus 2 equals 0, or the second term, multiplicand, is 0. So x plus 1 equals 0, and I can solve these two little equations. That means x equals negative 2 and x equals negative 1 are my x-intercepts. Plot my x-intercepts, my y-intercept, I plot my vertex, and I draw my line of symmetry, and we're going to use our imagination, in which the left side of this looks the same as the right side. Close enough is good enough. This is math, not art. Let's do another example. We're going to sketch the graph, finding all intercepts, the vertex, and the line of symmetry, where we have g of x equals negative x squared plus 4x minus 4. Just looking at this, I can see the negative in front of the x squared. Tells me the graph's going to open down. The negative 4, the constant term, tells me I'm going to have a y-intercept of negative 4. So a couple of things I can see right away without having to do any actual written math work, just observational math. My a value is negative 1, b value of 4, c value is negative 4. Here we go, my vertex. X equals negative b over 2a. So that's negative 4 over 2 times negative 1. Negative 4, a negative 4 is negative 4. 2 times negative 1 is negative 2, and when I divide, I get 2. When I substitute 2 back in for x, remember I'll do 2 squared to get 4, and then multiply by the negative, so a negative 4. Here I have a negative 4, so I'm up to negative 8. When I put 2 in for x, 4 times 2 is 8, so I'll have negative 8 plus 8 makes my y value 0, and I have my vertex at 2, 0. As I mentioned earlier, the y-intercept of 0, negative 4, I could plot. We'll talk about the symmetric point in a minute. I'm going to come back to that. The line of symmetry, always x equals 2. It comes to us straight from our vertex formula. Now, to find my x-intercepts, maybe I'll use the quadratic formula. And when I use the quadratic formula, the radicand, the fancy term for the thing under the radical, becomes 0. Oh, square root of 0. That's -4 plus or minus 0 over -2. Oh, the only x-intercept happens to be my vertex. That doesn't help much. If you have 0 x-intercepts or only 1 x-intercept, it's really hard to get the width on your graph the same on both sides. But remember, -4 is the y-intercept. And I can see that that's 2 units away from where the line of symmetry lies. Line of symmetry, it's a mirror reflection. So if the y-intercept is 2 units to the left of the line of symmetry, then at the same height of -4, if I go 2 units to the right of the line of symmetry, I'll have another point. And that's where the symmetric point comes from. Symmetric point uses the line of symmetry. I always take my y-intercept, find the distance it is from the line of symmetry, go the same distance on the other side, and I know I'll be at the same height. So if I go from 2 and I add 2 more, I'm at an x value of 2. I know my height is the same as the y-intercept. There I go, 4, -4. Third one. All right, h of x equals x squared minus 10x minus 60. My a value is 1. B value is -10. C value -60. My vertex is x equals -b over 2a, so that's a -10 over 2 times 1. So we'll take care of my negative and make a 10 in the numerator, a 2 times 1 to get a 2 in the denominator. Now I'll divide. 10 over 2 is 5. Don't get in a big old hurry reaching for your calculator here, because if you don't type it in your calculator correctly, it won't come out correctly. So do the little multiplications, the little handling the signs first. I'm hoping you don't need to do 10 divided by 2 is 5, but you know, we all freeze up sometimes. It's alright if you do. Just wait until you're getting to a point where you can enter it and get a good answer. Putting 5 in for x, 5 squared is 25. -10 times 5 is -50, so I'll have 25 minus 50 is a -25, plus another -60 gives me a vertex of 5, -85. My y-intercept we can read right off from our c value, 0, c, so that's 0, -60. I already found my vertex, so I also have my line of symmetry, x equals 5. Drawing my dotted x equals 5 line, we're going to pretend that's a straight line. Now, to find my x-intercepts, I'm going to set 0 equals x squared minus 10x minus 60. It's too hard. I don't want to waste my time with it. If my whole goal is to find the graph, to actually sketch the graph, I'm going to use a symmetric point. Technically, I should find the intercept, but I don't want to. So the symmetric point, notice here, line of symmetry is at x equals 5. The vertex is 5 units away on the left. The symmetric point will be 5 units away on the right. 5 plus 5 makes it 10. It'll always have the exact same height as the y-intercept. So I know my symmetric point has an x value of 10. I doubled my x value of the vertex. And a y value equal to the y value of the y-intercept. So I have a point 10, -60, and that allows me to get the appropriate width on both sides without ever actually having to find x-intercepts. Alright, why would we need this? For each demand equation, we're going to express the total revenue, R, as a function of the price P per item. We're going to sketch the graph of the resulting function and determine the price P that maximizes total revenue in each case. So we have demand function, right? Demand, quantity, in terms of price. Remember that revenue is always price times quantity. Right? I found a $20 pair of jeans. I'm going to buy 3 of them. The revenue the store makes off of me is 20 times 3 or $60. Same idea. So in this case, since my quantity is not, 3 pairs of pants, it's an equation. -3p plus 300 is going to be multiplied by p. P times -3p is -3p squared. P times 300 is 300p. And I have a quadratic function that opens down, which tells me I'm going to have a maximum revenue. That's good to know, right? I want to know if I can maximize my revenue. Now my vertex, I'm not going to use x equals because I don't have an x variable. I have a p variable. P equals negative b, so negative 300, over 2 times a. That's 2 times negative 3. I do my little arithmetic first. Negative 300 in my numerator, negative 6 in my denominator, and now I divide. Negative 300 over negative 6 gives me 50. When the price is $50, I substitute 50 back in for the price in my revenue equation. So I square 50 and then I multiply it by negative 3. I take 3,000, multiply it by 50, and then I combine the results. And it looks like my maximum revenue is 7,500. I found my vertex, 50, 7,500. Notice there's no fixed revenue. The y-intercept is at 0, 0. If you sell 0 products, you're going to get $0. If the price is 0, you make $0. But if we double the x value or the price value, the p value of the vertex, 50, right, double it, we get 100. We'll have the same height as the y-intercept, so 100, 0. I have a basic idea of the graph. Yeah, remember, math, not art. It's all right. And we can see the price, $50, maximizes revenue with a maximum revenue possible of 7,500. It's just quadratics. It's just vertex, intercepts, symmetric points, and we can answer all the questions necessary. Let's do this again. For each demand equation, express the total revenue R as a function of the price P per item. Here's our demand. Q equals negative 5P plus 1,200. Remember, revenue is always price times quantity, so negative 5P times P is negative 5P squared. 1,200 times P is 1,200P. And I have my revenue function. R of P is negative 5P squared plus 1,200P. Price times quantity. So multiply every single term by P and we'll have our value. Now that we have the quadratic, the price P is negative B, so negative 1,200, over 2 times A, so 2 times negative 5. That's negative 1,200 over negative 10. Negative divided by negative is positive. 1,200 divided by 10 is $120 as our price. When I put $120 into my revenue function, ask the price, a little bit of magic occurs. It's really a calculator issue probably for most of us. 72,000 is our maximum revenue. How do I know it's a maximum? My parabola opens down. A parabola that opens down will always have a maximum. My y-intercept is 0, 0 because if the price is 0, I make $0. And if I double my price, 120, double it to get 240, I'll be at the same height, my symmetric point, as my y-intercept. So a price of $100 maximizes the revenue. $120 maximizes the revenue, and that maximum possible revenue is $72,000. The exact same as we had in our previous examples. Alright, I'm going to leave this one here. I'm going to cut this lecture into 2 different videos. I like to keep the videos kind of short. So this is it for the basics of quadratics. A few more word problems, more wordy, hopefully not quite as bad a problem, coming soon. Thanks for listening.